Today we are going to establish the relationship between the current and electricity, where we believe, as per the first law of thermodynamics, the energy creation or destruction is not possible, but the conversion of one form to another is definitely possible. So here we will be focusing on the conversion of electrical energy. That means by passing the external electricity, we are going to carry out the stubborn chemical reactions. The second point being the conversion of chemical energy. I mean, if you carry out any spontaneous reaction, you are aware that energy will be released, and that energy you will be using to produce the electricity. So this way we have classified the chapter electrochemistry, and the process 1, where you have converted this electrical energy into the chemical energy, is called the electrolysis, whereas the second one is referred as electrochemical process. So there are two processes which are being studied. Now, in order to study this, we need to first of all know what exactly is the conductor. Although there is little connection between the concept that we study in physics and that in chemistry, we will broadly classify them according to the chemical reactions and chemistry terminology. So here we should understand first what exactly oxidation and reduction means. As we are aware of the fact that the reduction in a redox process is the gain of the electrons. So we believe that when electrons are being captured by any species, it is going to get reduced. Reduction of what? Obviously the positive charge. What I mean to say, that if copper ion from the solution, say I have got the aqueous solution of copper chloride or copper sulfate, which is upon supply of the 2 moles of electron is going to convert into the metallic copper. So here you can see clearly that the oxidation state of the copper has changed from +2 to 0. So there is change in oxidation state, or rather there is decrease in the oxidation number of the copper. The process is known as the reduction. Or you have the permanganate ion which get reduced in presence of the strong acids to give you the manganese ion along with H2. So here you can see that the oxidation state has decreased by virtue of the gain of electrons. So this process, as we are aware, we are going to use, we are not going to use the terminology that the absorbance of hydrogen or loss of oxygen. Rather, we are going to use the terminology here, the gain of electrons. And you all know oxidation is quite opposite, that is loss of electrons is reverse to what you have seen here. So when electrons are being lost, for example, you have the aluminum is getting oxidized in presence of oxygen or air to get converted into the Al2O3, where the change in oxidation state is clearly seen as 0 to +3. So there is increase in oxidation state. There are positive charges on the right side, there is neutral charge on the left side. So in order to compensate, you know, like 2 moles of aluminum, and there are 3 oxygens, and when you have balanced everything, you will see that the total amount of charge lying this side is +6. Hence you will be writing 6 moles of electron, because the net charge that is available on the left side is 0, hence it should be 0 on the right side, for which you are adding the electrons in the product side. So aluminum has lost the electrons, and hence the oxidation state has increased from 0 to +3. So this is considered as simple oxidation reactions. Now when I am clubbing these two, when I am writing a redox reaction, say I have with me the dichromate ion, which is going to act as a powerful oxidizing agent in the acidic medium only to convert the sulfide ions. So you can see there that the oxidation state of sulfur is being -2, and chromium in acidic medium will change its oxidation state from +6 to +3. It has undergone the reduction for the reason that sulfur might have undergone the oxidation. So here this is a redox reaction. Now when you try to compensate the moles of electrons that have released or absorbed, what you will do? total chromium that are present on the left side are 2, we will be writing 2 chromium, and you have to compensate the charge also, for which you will take the sulfur also into account. You can see here that there is one sulfur changing its oxidation state from -2 to 0. So here sulfur is undergoing oxidation, chromium is undergoing reduction, and moreover you can see here that the total amount of charge which is accounted for the chromium is the change from +12 to +6. That means how many moles of electrons have been gained by the chromium? Total 6 +12. You can see 2 into chromium is +6 to +6 to 12 to 6. The moles of electron that are absorbed by the chromium are 6. But when it comes to this sulfur, it has lost -2 to 0, only 2 moles of electron. You know, in a redox reaction there is a policy that the moles of electron that are released and gained or absorbed should be equal. So since the electrons that are absorbed here or gained here are 6, they should be 6 here, for which, as you all know, that you will be writing or compensating this by writing 3 moles of sulfur. And when it comes to the oxygen, clearly you require 7 moles, and when it comes to the total amount of the hydrogens, they are 14. Now you say this equation is balanced, hence it is a balanced redox reaction.